Mobile devices are becoming more and more advanced each year. The current generation of Android phones use dual-core processors and plenty of memory to multitask applications. With the increasing power of their hardware and a large modding community surrounding this platform, the possibility of malicious attacks being performed from a mobile device is increasing. Recently, a simple app made its way onto the Android market named Wi-Fi Kill. As the name suggests, it allows the user to, quote, kill the internet of anyone on the network. This app requires root access, however, so Android phones cannot perform this attack out of the box. Here's an example of a stock phone. As you can see, it is rather slow and loaded with applications from the manufacturer. Rooting will allow for changes to be made to the system directly and give the user greater control over their phone. The process of rooting is different for each device. It usually involves finding an exploit of the phone's operating system. A large community has surrounded this aspect of Android, and methods of rooting are widely available. The software shown here is for the Motorola Droid 3. Other phones have different methods of obtaining root access. I highly recommend it if you're using an Android phone, but please note that doing this voids the warranty. Now that the phone is rooted, we are able to perform the ARP spoofing attack. Wi-Fi Kill is recently pulled from the Android market, so you must download the APK file and install it manually on the phone. This attack has been running in my dorm for about 10 minutes, and as you can see, I was able to spoof about 100 machines off the university network. One problem I ran into was that the university uses different subnets for their network. I was not able to ping my desktop as it was on a different subnet than the wireless. However, I was able to deactivate over 100 devices, creating a very effective denial of service attack. Now for the inner workings of this attack. Using the wireless card on the phone, the app sends out ARP requests through a range that is set by the user, seen here in Wireshark. The phone then broadcasts that it is the default gateway for the network, so that all traffic is sent to the phone. If the user then selects that it wants to deny an IP or MAC address, the phone then drops the packets from the user. The user is still connected to the network, but no data is being sent outside. Lastly, I wanted to test to make sure that the devices were actually being denied. So I pinged the address 10.24.27.19 in order to confirm that it was live. After confirming that the address was accepting pings, I went to my phone and denied it. After waiting for the attack to take effect, I went to my computer and pinged the device. It returned a timeout response, which is what I was expecting to happen. While this version of the application is a bit rudimentary, the developer has stated the next version of this application should have an HTTP forwarding option built in the next round. This would allow a user to forward the connected users to a website, perhaps using a phishing scheme to steal confidential information. Thank you for watching.